which is by me, by learn together. Firstly, we have to know what is a whole number before studying its properties. Okay, so the whole numbers is a number from 0 to infinite. What do you mean by infinite? Infinite means never ending. Infinite means never ending. And the natural numbers come inside it. It starts from 1. So in natural numbers, one digit is missing. It's not missing type of, but one digit is not added, which is added in whole numbers, which is 0. That is why the whole number circle is very big. So in the chapter whole numbers, we are going to learn about whole numbers. This is very clear. And today we are going to learn the properties of whole numbers. What are whole numbers that we got over here? What are the properties of whole numbers? Let's see that. First, the closure property. The closure property states that adding or multiplying two whole numbers will always result in a whole number. Either the sum or the product, they will be in whole numbers. This property applies to addition or multiplication. And always remember whole numbers. Let's now check it on paint. So, for example, we have 20 plus 22 maybe. These both are whole numbers. As you know, they are in middle from 0 to infinite. Okay, these are between 0 to infinite. Now, what is the answer? It is obviously 42. So, 42 is also between 0 and infinite, and that is why it is a whole number. So that is one example. You can test with any number and make sure it's a whole number. And zeros are also included in the whole numbers, if you are wondering. Now, how do we know it works on multiplication? We don't know if it works or not. What are examples there for then? Let's learn about why it applies on multiplication. First, let's take a number 2 into maybe 8. 2 into 8 means 2 into 8 is 16. 2 into 8 and 16. 2 and 8 and 16 are between 0 and infinite. What does this mean? This means that they are whole numbers. They are whole numbers. So it means that if I multiply any two whole numbers including 0, the answer or the product will always be a whole number. And this is obviously the property of whole numbers. So in the closure property, we get to know this. Now let's go to the next slide. We were learning about closure property. Recap. Okay. Now commutative property. What is commutative property? We are going to know. So the commutative property states that adding or multiplying two whole numbers and reversing their order won't change anything in the result. Anything. This property applies on addition and multiplication. Why? So we're going to know why does it apply, why does it not apply on subtraction and division, or commutative and closure. Let's continue. Yeah, so we were learning this. Now let's know why does the closure property not apply on subtraction. First, if I subtract 1 by 1, maybe both are whole numbers, and 0 is also a whole number. Maybe you want to take some more like definite, more good numbers or more larger. Let's take 772 minus 20. Maybe any two whole numbers. What is a whole number? We know about it. So the answer would be 52. So what if I reverse this order? You will say that, ma'am, this is the commutative property, but actually we're just going to put 20 over here and 72 over here. So, will this be possible if we don't want to answer in minuses? We want from 0 to infinite, which is the whole numbers. No, it can't. The answer would be minus 52, which is not a whole number, which is not a whole number. Okay, the minus numbers are integers. So minus 52 or minus anything, minus 1, minus 2, minus 3, minus 4, minus to infinite, minus 1 to infinite, it is not a whole number. So the the closure property does not apply to subtraction and division. Why? How do you know it doesn't apply to division? Huh? Okay. So first is a very simple definition. First tell me what is simply division? What is simply division? Division is, oh my god. So division is simply repeated subtraction. Division is simply repeated subtraction. Okay. So we have to subtract and subtract and subtract and subtract now in division. So what doesn't apply to multiplication, minus or subtraction will not apply to division. How? Let's take an example. 6 and 3 and 27. Both are whole numbers, you know. The answer would be 9. 3 nines are 27, as you know. 0 remainder. Full answer. Isn't it? This is a full answer. Now, what if I want to change this? What if I want to minus? What if I want to divide 1 by 2? What if I want to divide 1 by 2? What will be the answer? The answer would be 0.5. How do you solve it? If you see on a scale, you will get everything. Okay. So, the half of 1 is 0.5. Okay. And 0.5 is a decimal number. It does not come in whole numbers. What does a whole mean? Full. What does a whole mean? Full. And this is a part of a whole. This is a part of a whole. Okay. This is a part of a whole. You can say it is 0 by 5. So it is 0 by 5. So it is not a whole number. The denominator here is not the whole number, as the fraction denominator, the whole fraction is the part of a whole, is the part of a whole. What is the definition of fractions? It is fraction is the part of a whole. And decimals, you can write fractions in decimals. So it simply means that decimals is also type of fraction only. Decimals is also a part of a whole. And we are talking about whole here. We are not talking about a part of a whole. You understood? So decimal satisfied does not come in your whole numbers. Okay, so that means that it doesn't apply to either a subtraction or a division. But you can just easily understand that what applies to subtraction will apply to division. What doesn't apply to subtraction will not apply to division. Now we were talking about the commutative property. So let's just read the commutative property again. The commutative property states that adding or multiplying two whole numbers and reversing their order won't change anything in the result. Let's first write a simple thing. A into B See, this is multiplication, by the way. Okay, let's A plus B addition. First, let's say A plus B is equals to B plus A. What is this BA? What are these letters? Maths is not numbers, not letters. So 1 plus 2 maybe is equals to 2 plus 1. The answer would be the same or not. This is also 3 and this is also 3. So it simply means that A plus B is equals to B plus A. Okay. So this is the first formula of commutative property. Let's just select it. We're going to move it over there. Done. This is the first one. Now, what about multiplication? So you first, let's say addition. 2 plus 26 is the exactly same as 26 plus 2. And both the answers is, by the way, 28. So it is the same. Now what about multiplication? Let's do it. Let's try. 2 into 6 is equals to 6 into 2. That is obviously 24. I'm just joking, it's 12. So 2 into 6 is equals to 6 into 2, which is 12. Now both the answers are the same. Both the answers are the same. So we also know that this applies to multiplication. So what can we write for the formula of multiplication? A into B is equals to B into A. Okay, P into A. You may take screenshots of both the formulas together. You just write them. Okay, so A into B is equals to B into A, and B plus A is equals to A plus B. Again, we don't have anything for subtraction and division. Why so unfair? Okay, let's just try. Now, 52 minus 20. Okay. And 20 minus 52. We did type of these questions, but let's do it again. Okay, so when you do both the sums or both the questions, you get these answers minus 32 and 32. Are the answers same? Are the answers same? No, the answers are not same. So what can we write to prove this? That this is not applicable on subtraction. Let's make a formula for that. A minus B is not equal to B minus A. I hope you're understanding everything. So this is the formula of subtraction. And as I told you that what doesn't apply to subtraction will not apply to division. So this can also be written. This is very easy formulas. You don't have to learn them. It's simple logic. Okay, simple logic. Both are different. So you'll say, yeah, both are different. Okay. Now let's go on to the next property. Recap, we were learning about commutative property and social property. Associative property. What is associative property? So let's see the definition, then we'll do everything. So the associative property states that the way in which the multiplicands are grouped in a multiplication problem does not change the product. Okay, as we know from the statement, it is about multiplication. It can also go for It can also go for your multiplication plus also. Let's just have some examples. Do you like examples? I to do. Okay, so let's just solve this example only. 54. Okay, 5 into 4 into 2. So what if I group these two together? 5 fours are 20, 22s are 40, 22s are 40. Now let's back everything. What if I do this? 4 twos are 8. One second. Yeah. So 4 twos are, I was just checking if I was right. 4 twos are 8. 8 fives are 40. So the answer was the same. The answer was the same. Let's make a line and solve it. Let's make a line and solve it. This is going to be the differentiating line between both the sums. Let's do both the sums together. 5 into 2. Let's change. 5 into 2 into 3 maybe. So this will come as 10 and this. And if we multiply this into the number over here, the 10 into number 3, we will get 30. And the answer is also 30 over here. And what if I don't group like this? I group like this. Now what will happen? 3 2s is 6, 6 5s are 30. Okay, 6 5s are 30. This will come as 6 into 5 is equals to 30. The answer here is also 30. So this proves the commutative property is for multiplication. It is for addition also. So, but always remember the whole question, maybe 5 into 2 into 3, which is like maybe like this, they all should have only one process thing. Okay, only one fundamental operation. We should only use only one fundamental operation to prove the associative property, right? So what if I do different? What if I do this as plus? The associative property doesn't work on that. As you know, all these whole numbers property will not work on natural numbers now. So maybe they are working, but we don't know about it right now. So now let's go on the next. Recap, we're learning about the associative property. Now, distributive property of multiplication over addition. This was a big one. Okay, so you are going to learn this. It's very easy, but it looks hard. The distributive property of multiplication over addition is applied when you multiply a value by a sum. What do you mean by this? What do you mean by? Okay, so here you won't understand with this. Okay, so let's have a look. Okay, maybe you want 26. Your operation is 26 into 101. That's a big number. Do you want that old traditional way? Do you want a fast trick to do that? That is what distributive property is about. Isn't it fun? The properties are teaching us tricks. So we can also write this question as 26 into 100 plus 1. You can also write this now like that also. 100 plus 1. Okay, 100 plus 1, that is 101. So now how to do this? First, okay, let me just delete this. Yeah. So first, we are going to multiply this 26 by 100 and then 26 by 1, and then we are going to add both the products. So what is 26 by 100? 2600. What is 26 by 1? 26. 26 ones are 26. What is the answer? 2626. Is the answer correct? Let's check it on calculator. 2600. Okay, no, not this. 26 into 101. The answer is the same, 2626. 2626. Wasn't it so easy? You would have taken a lot more time than this in multiplying the traditional way, you know, isn't it? So it would take time, but this is a time saver. So you can say it as a trick, but you have to learn the trick. So the distributive property states this. Okay, this was a very easy this was a very easy you can say definition and definitions, or the properties. These were very easy properties, but I know that these all properties will help you in the further maths. That is why I'm teaching you. So a small recap, that we have learned about what is a whole number, what is a closure property. The closure property is it states that adding or multiplying two whole numbers will always result in a whole number, which is working for addition and multiplication. The commutative property states that adding or multiplying two whole numbers and reversing their order won't change anything in the result. This property applies on addition and multiplication. So we also learned about the commutative property. Now we also learned about the associative property, which is that the associative property states that the way in which the multiplicands are grouped. What is the multiplicands? These all numbers are the multiplicands are grouped in a multiplication problem does not change the product. We also learned about distributive property, which is of multiplication over addition. The distributive property of multiplication over addition is applied when you multiply a value by a sum. So thank you so much. I hope you liked the video. If you want to ask any doubts, you can email me down at this email. Format will be linked in the description. It would be typed in the description. You have to type like that, or you would get a flat little response. Wrong format. So you just have to see this email. If you have any doubts, just message it and you'll get a reply soon. So thank you so much for watching. Hope you have a wonderful day ahead. Take care and bye bye.